Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account. Hi everyone, today we have with us Emma Wilson, who is a PhD researcher at the ARC Center of Excellence for Nanoscale Biophotonics at RMIT University in Australia. Hi Emma, how are you doing again?
I'm excited. I'm excited to be here. It's going to be fun, I think. So yeah, I'm looking forward to it. Thank you. Thanks for the invite.
Our pleasure. Very happy to have you. So let's start by understanding, how did you end up in your current research field? What's your journey been like?
Yeah, it's been a long one, and a not necessarily very traditional one. So perhaps if everybody makes sure they've got a cup of tea and a comfy seat, because it's a bit of a long story. But I hope it's one that might maybe inspire people who are sort of sitting back in a different career, wondering whether or not to go to university, or wondering whether or not they're smart enough to study science, or, you know, just change things up, go and do anything, even if it's not science, if they're just feeling a little bit dissatisfied in their life, and go and do something else. But I started out, I left high school when I was 17. I quit in year 11 to go and do an apprenticeship as a chef. And I sort of spent close to 2 decades in the hospitality industry working as a chef. It took me overseas. I met my husband because of traveling and working in pubs and things like that. I've run businesses. I've run my own business with people. I've worked in catering. I worked on the Olympics with being a chef, and it really was, for such a long time, a really great career. And I got so much out of it, and it was really rewarding. But about 10 years ago, I think it is now, my mother got sick. She got diagnosed with cancer and she passed away. And I'd sort of started to feel a little bit dissatisfied in the hospitality industry. It's sort of hard to explain. I was enjoying it, but I also wasn't particularly. And then when my mum passed away, I kind of really realized that you kind of only get one shot at this, and I'm not happy, and there's only one thing that can be done about that, and that's make a decision to do something different. And so I sort of asked my husband, I sort of said, what do you think? Is this okay? And he was really supportive and said, if that's what you want to do, then we'll make it work. You know, obviously going back to university full time meant there was going to be a bit of a halving of salaries, so to speak. It wasn't quite that bad, but, I was lucky to have that support. So I went and looked at a couple of different universities here in Melbourne. By this stage, we'd moved back here. And RMIT offered a food technology, a food science degree. And I thought, well, that could be really interesting. And I could, I've got food skills, talking about food. I can talk that language for sure. So I went and started initially in the food technology degree. However, it's still, when I was talking with people from industry and also some of the lecturers in my first sort of semester in that degree, I quickly realised that I wasn't going to find that satisfying, and that what the food science industry and my connection to food were sort of different in a particular way, and it probably wasn't going to be that. It wasn't going to be for me, I think. I kind of picked that up quite quickly, but I happened to have done an introductory course to genetics, molecular biology and microbiology in my first semester, which is a subject that most science students have to take at RMIT. And I loved it. I was hooked. Just hearing about what's going on inside our cells and all of the molecular machinery and all of the ways that we study it. I went, this is too cool. Like, I can't pass this up. So I went and spoke with the course coordinator from the biotech degree. And initially I thought maybe I'll go into sort of clinical medicine, or rather into laboratory medicine, not clinical medicine, laboratory medicine. But she sort of said, no, I think what this conversation has led me to believe is you're biotech all the way. You've got that kind of interest and curiosity that will potentially go a long way in that kind of industry. There's lots of jobs in Melbourne, in Australia. So I went, okay, well, sign me up. Let's do that. Let's go into biotechnology and genetics. And that's what I did my undergrad in. And I loved it. I had such a great time. I maybe because I was a little bit closer to my lecturer's age, I just found really great rapport with a lot of them. I found some excellent mentors, people who are still mentors today. And I just hit the ground, and I just found it, I just absorbed it like a sponge. And I was like, I've done the right thing. This is where I need to be. I really enjoyed it. You know, I was quite disruptive in high school. I was a bit of a rebel, and I was constantly told that I wasn't very smart, and I was constantly told I wouldn't be good at this and I wouldn't be good at that. And I think it was because I was a little bit maybe over curious, but didn't have the maturity to express that in a way that my teachers could appreciate. And they just saw me as being argumentative. So when I was asking why, I would get, so I don't necessarily blame them, but I feel like there was this big part of my formative years in high school where I was really dissuaded from my intellectual potential, my academic potential, and my scientific curiosity. Thankfully, though, I grew up in a family where that was encouraged and we discussed those sorts of things. So it was never fully squashed. It was just discouraged from an academic pathway. But as I, got a thicker skin being a chef and kind of learnt who I was as I got older and moved through life as well, I kind of was able to reflect and look back on that early academic life in high school and go, no, they're wrong, actually. I have the potential to do well in academia, and I have the discipline, and I've proven that to myself. So that nagging voice still sometimes rears up a little bit, I'll have to admit, that kind of negative talk voice. But I did really well in undergrad. I really found my stride, and I met amazing people. So initially I thought at the end of my 3-year degree I would get a job in industry, and I'd go out into maybe pharmatech or, agrobiotech or one of the sorts of industries and hit the ground running and go off and do something in that. But I got talked into doing an honours year because somebody said, well, Emma, you've never really done research. I had done a few little studentships and things like that in undergrad. But I hadn't really ever done research for research's sake, they pointed out. And I went, oh, okay. So they said, give an honours research project a go. In my final year of undergrad, I had been doing some work at the Florey Institute here in Melbourne, helping sort of design GFP plasmids, green fluorescent protein plasmids, which is sort of the genetic thing that we insert, how we get the genes in to make other cells express the GFP. And during that sort of process, I kind of got my passion for things that glow, things that make light, or we can make light. Right. But I also got curious around the instruments and the tools that we use to study those molecules and biology and genetics and all of those sorts of things. There was too many times I'd sort of, point to a button that had just been clicked or a number that had just been added into the instrument, and I'd be like, okay, so why did we set that to 10, and why did you uncheck that box, and why does that say that? And a little too often I was just getting, oh, that's how I was told it was done, and or that just seems to work better than not having it done. And I was like, but is it an algorithm thing that we're making the instrument do, or is it a physical thing that we're making the instrument do? And I wasn't getting satisfactory answers. So I went, well, I can't just come and study fluorescent proteins. I need to kind of understand these instruments that we use. What are they doing? And the tools that we use, like what's going on with these tools? And so I decided for my honours year, instead of sticking in the more classical biotech, molecular biology pathway, I approached a physicist at RMIT, Professor Brant Gibson. He had supervised me a few years before on a project called the professional scientists we do at RMIT, where you get to sort of explore what it is to do science communication, and what it is to sort of do research at a very, very basic level of reading papers, literature reviewing, that sort of thing, and working in a team collaboratively, which is a huge part of the sort of science that I do. And I really liked him, and it was at the very, very start. They just kicked off the ARC Centre of Excellence for Centre for Nanoscale Biophotonics, or the CNBP as we call it. And so he was telling me a little bit about that, and I was like, wow, this cool centre where you've got physicists and biologists and chemists, and there's theoreticians and mathematicians and clinicians and all these like people from like the whole world of science and coming together to examine and explore some biological questions. And I just went, that's so cool. And it really stuck with me, and his approach and just his kindness and his generosity really stuck with me. So I went, well, if I'm going to give research a go, this seemed like a really cool person, really smart, but also kind, which is important to me. I want to work with kind people. And this centre seems like super exciting. So I thought, why not go and ask him? Worst case scenario, he says no, but he didn't. He said yes, but also because his field and my background was so far apart, the university suggested that we teamed up with somebody from the chemistry department, and that's where in my honours year I got to work with Professor Vipul Bansal. And they do a lot of work with nanomaterials and bio-nanotechnology, particularly around looking at nanozymes, which are basically just nanomaterials that mimic enzymes. And they're really cool. So my honours project was taking the material of Nanodiamond, which was Brandt's background, and the concept of nanozymes, which was Vipul's background, and trying to mesh them together and study them for any sort of enzymatic like properties that they might have. And I really enjoyed it. It was really exciting. It was really, really interesting. And it was just, and I kind of went, oh yeah, this research thing's fun. It's a lot of work, and it was very stressful. Your honours year it's like you cram all these things into essentially 9 months with coursework and then a minor thesis and all this sort of stuff. But I kind of went, I get to go to work and play with cool toys and talk with people who are passionate about what they do and understand how these cool toys work to a real level where I can like really get into, is this experiment, does it make sense? Has what I've done made sense? And I just I really liked it. And I had no intention of doing a PhD, like, just to be perfectly honest. It was so far from my mind. And then somehow I got talked into it. I hope that doesn't sound sort of like I don't appreciate my situation and how lucky I am, but I kind of got persuaded to apply, and another supervisor who was on my honours, Dr. Philip Reineck as well, who's still one of my supervisors now. He was really cool, and he kind of came up with this project of looking at the nanodiamond size. And that's where I kind of fell into the physics department at RMIT. So by this time I've been a chef, I've been in the food science department, I've done a little bit in biology, in the hardcore biology department in undergrad as well, and then I've gone into chemistry and looked at nanomaterials, and then I find myself in the physics department, and that was a real surprise and also really pleasant. It's the RMIT physics department is a really solid group of researchers. The right from the dean all the way down, there's lots of, well, pre-COVID, lots of good social events and just people talking and hanging out and discussing their science and things like that. So that was really nice as well. And then basically that sort of led me to here, where now essentially my PhD is, I no longer look at the nanozyme effect. I now am purely focused on fluorescent nanodiamonds, and I study the role that particle size has, or the effect that particle size has on the fluorescence properties of the material, as well as their the way they interact with biology at that nanoparticle biological interface. So what does the biology do to what does the biological environment rather do to the material, and how do they affect sort of normal biological function, things like their ability to replicate and their viability, produce energy, reproduce their DNA, things like that. So yeah, so that's sort of where I'm at now. So it was this kind of weird journey to get there. So
it sounds like quite a journey you've had, and you just have so much experience from so many completely different fields or walks of life. Like being a chef, getting a degree in food sciences, now working with chemists, physicists, biologists, clinicians as well. So you're basically trying to cover everything. Did I leave any of the main branches out?
I didn't finish the food science degree. That's where I sort of started my uni degree, and it was great. And don't get me wrong, I think food science is amazing. It just wasn't. It wasn't for me. I felt a draw, almost a calling to go to the genetics and the molecular chemistry, biology sort of things, and I think that's really how I've ended up where I am now, is because I made that decision to sort of go and explore things a little well and truly outside my comfort zone. You know, initially I went to university going, well, I'll stick with food because it's my comfort zone. But I made that, and I was lucky. I was able to make that decision and go, that's not for me. Actually, I need to do something that's wildly different to what I've been doing. And I think that really has been my academic journey. Each step of the way, I throw myself out of my comfort zone to kind of push myself to explore things and to look at things from a different perspective as well, to kind of help create. You know, essentially that's what we're doing in science, is creating. It's a creative field. It just has it has rules and principles that guide it, you know, because we're also trying to get to fundamentals and understand things. But at the end of the day, it's a creative field, and I find for me being outside my comfort zone helps me with that. So sometimes can be challenging as well. You know, it's stressful not being comfortable. It's, you know, it can be hard, and that's where, like I said, why it was really important for me to find a supervisor or a supervisory team that is kind and supportive, and also shares that value, that common goal of being creative, but also, you know, being happy is important. So I was just going to say, and that's really, you know, that really is the centre. I've been so lucky in my PhD. The centre, it was a really good decision in that, you know, there's high expectations. We really must hold ourselves to very high account, but we are given so many great opportunities as students in the centre, and even at RMIT. You know, I mean, we're really, really lucky of the access. Like I said, access to all the cool toys. You know, you get cool toys, and if you kind of have an idea that maybe somebody else's cool toy might help you explore your science, people are open to you approaching them and saying, can I use your cool toy to look at this? Do you think it might help answer this question? And you can have those open and honest conversations, and I like that. I mean, you get to play. It's, you know, you've got your purpose, but you get to have fun, and that's cool. That's, you know.
Yeah, that's really cool, and I'm glad that you found your calling. I do have one question though that comes to my mind. I mean, this journey has been super fantastic. If you were to go back in time, would you still choose the career path that you did? Like, would you be a chef, then start food science, or would you rather jump directly to where you are right now, or try to follow this conventional path, so to say, that, okay, getting your bachelor's, your master's, your PhD, and would you do that? Would you choose a different career path?
Knowing who I was in my youth, I don't think I would have done well in academia back then. Even if you exclude the kind of dissuasion from some of my teachers, and not all of my teachers. I've had some brilliant teachers who were really encouraging of all that sort of stuff, regardless of your aptitude. They'd be like, if you're interested, it doesn't matter, you give it a go. But regardless of that, I think I think I wanted different things. My priorities were different when I was in my teens and 20s, early 20s in particular. You know, I mean, I have depression, which comes in episodes. I don't have it constantly. I have depressive episodes, and I struggled quite a lot with that in my younger years, and I don't think academia would have been a particularly good place for me necessarily back then. And I don't think I would have excelled. I don't think I had the priorities to have the discipline to study in that way. Whereas the discipline to study in an apprenticeship is very different. You're going to a job, and you're in a team in a particular way that if you don't show up and do your job well, you let your mates and your colleagues down. Whereas academia doesn't have that. Really, at the end of the day, if you don't show up and do your study, it's you that suffers. You pay the fees, and then you don't really get that great learning experience out of it. And I think in my youth, I needed that direction and that team thing to kind of help me how to learn how to prioritize what's important to myself, how to also just grow a little bit and develop as a human. So short answer to that really is no. I don't think I would. I don't think if I had a time machine I'd go back and tell myself to do anything different. I had a lot of fun as a chef. You know, it was a really good career, and I can knock together a meal really easily, and I love food. I love being able to share that with people as well. It was just eventually I grew out of wanting to do it as a career. It's just stopped holding that main passion for me, and I just recognized it was time to go and explore something different and do something different. And so I was really lucky that I had a support network around me that I was able to do that. You know, and I think and I guess if anybody's sort of out there and they have a career, or they even just have a job and it's not really a career. Being a chef was a career for me. I was really serious about it. I really, you know, I lived it. I lived and breathed it. But even if you've just kind of got a job, but you think you might want to do something, I say go for it. And to go to university, you don't have to have, you know, got all A's. You don't have to, you know, have done that well in high school. I mean, I didn't even finish high school. You know, that I just kind of got so dissuaded from it. I just went, well, you know what, I'm going to go and do something else. If I've got to do this learning thing, let's go get paid. That's the beauty of trade, you know. You go and get paid to learn and travel the world and things like that. So, which is similar to you know some of what goes on in academia as well. But yeah, no, I think my pathway. I think it's what makes me unique. I think the fact that I've had this other experience in life, and I think it's given me courage to be able to go, like I said, just go and ask people. If I want something, I have that. I'll just go and ask them. I've got that boldness. Because at the end of the day, the worst thing they can say to me is no, we can't do that, and that's really, it's not so bad. That's not so scary. So,
True. Oh, that's really nice. I was kind of hoping that you would say no when I asked you that question. Like, yeah, please say no, because you've had such an amazing path. Your career has taken you places. That's what you are today is basically what your career was and the life that you've lived, right? So it makes sense to not change it, even if you have the chance, because you had fun, you were having fun, and that's the most important thing.
Yeah, and I mean, that's not necessarily to say there aren't moments I might not go back, and I might maybe go back and handle a little better with a little more wisdom and maturity. But also that's part of learning, and that's part of life as well. If we came out wise old peoples as infants, then life would be really boring. Part of it is learning and making mistakes, and that's a really important thing to sort of understand, is that it's okay to make mistakes. And I think that's something I didn't really appreciate in my youth, which I think is also why I probably wouldn't have done so well in university in my sort of teens and 20s, because I wasn't so good with this concept of making mistakes, or being criticised for mistakes. Whereas now I actually really I embrace the challenge and the questioning and the learning and growth that you can kind of do from when you make a mistake, you know. So yeah.
Okay. That's yeah, that sounds good. That sounds really good. So, moving a bit towards the scientist part of your life now, the scientist part. From what you mentioned, you have had a very interesting switch of topics to a certain extent.
Yeah.
So it sounds like you were involved in a lot of interesting research projects.
Yeah.
And if you have to pick one that you're most proud of, or the most fun or quirky one, I know it's difficult because you have been involved in several different projects, but if you have to pick one, could you pick one research project that you were part of that you're most proud of and explain it to us in simple words in the section we call In Other Words?
When I really think back to all the projects that I've been involved in since coming to study science, was probably maybe my most proud was my first research lab job, which was a summer studentship at the St. Vincent's Institute for Medical Research's National Serology Reference Laboratory, or the NRL, where I've actually just taken up a part-time job with, which I'll discuss a little bit later, I think. But the project I did with them when I was an undergrad, I had just completed my first year of undergrad, was working in HIV studies. So one of the roles of the serology reference laboratory, or the National Reference Laboratory, is to help supply diagnostic and testing labs around the world and around Australia with standards for them to run, so positive controls and negative controls and different types of standards to run while they're running their diagnostic tests with their patient samples. And at the time, the NRL was working on a HIV project, which was trying to address the issue of DNA stability at room temperature. So lots of biological molecules don't like to be at high temperatures or at room temperature. They start to degrade. And obviously one of the big things in HIV research is helping the whole global community. And so that's also dealing with nations that don't have the same kinds of resources, from just stable electricity to run refrigerators and freezers within labs around their country and things like that. So this project was about developing and testing the viability of dry tube samples of HIV DNA, so the extraction of the DNA virus. Would air dry out the samples and then let them sit around at different temperatures, from frozen right through to room temperature to quite warm. So sort of simulate temperatures that might get around the equatorial belt, and then see whether or not after, a day, a week, a fortnight, up to sort of 6 months, whether or not the integrity of those standard samples was maintained to a point where they would be valid for testing or using, whether you would still be able to get the correct result as a positive or a negative control for your test. And that really, for me, I was really proud of being able to be part of that. I think I was proud of the fact that I could, from a personal perspective, just sort of learn how to work in a professional lab, and that it solidified for me that actually I've made a good choice here. I think I've got a brain and a personality that sort of suits this methodical approach that you need for working in science and studying things. But on a global scale, I think I was really proud of the fact that I was doing something to help the world and to help the broader community. HIV is still a really big issue in many countries in the world. Even here in Australia, it's still an active viral pandemic. And the thought that I was doing something that had potential for real world impact and to help improve the quality of life for people who I'd never meet, I'd never know, we'd have no other interaction, but just being able to provide them with So this was for viral load. This wasn't diagnostic, but this is about helping to understand if their drugs are working to maintain and to manage their disease. And, and that's such an important part of HIV clinical care, is understanding viral load. And that's relatively easy in a country like Australia. And then when I sort of thought about it, I was like, well, it is when you live in a city in Australia, but we have regional and rural areas even within Australia. So I was like, so even though this is sort of aimed at helping the global market, it's going to have kickbacks that really impact my community and my family, my mob, the Australian people. And I'm a rural girl. I grew up in the country. So I was like, yeah, this is me. This is what I want to do things. I want to leave the world better than what I came into it in. And I think that's what a lot of scientists want. So I think I was really proud of that, because I went, I can do this, but also I can do this and it can be meaningful and it can be impactful potentially for people around the world. So, yeah, and that sort of, yeah, that was, I think that kind of, to me, sort of solidified the proof that you can do this. You've got this. You got this, girl. Yeah.
Okay. All right. Yeah.
And it was, I'm proud to be, I was just sort of going to say, and I'm proud that I've been able to maintain that relationship, and then I've been able to come back and help do some work with them again while I'm wrapping up my PhD as well. So some COVID related work. Yeah.
This is so cool. I can completely understand why you're proud of this particular research project. I'm sure you're proud of most of your 99% of your research projects that you've done, and I can completely understand. And this is so amazing. Like, you're kind of like completing the circle or widening the circle a little bit. You started with, and now that's what you're doing at this point, and hopefully you will do it for a longer period of time as well, either as a main task or something in parallel.
Yeah, thank you. Yeah, it is. It's good. And it's the NRL is it's a great team, great people to work with. So again, that theme, that common value for me is always work with good people.
That's the bottom line. Always work with good people. You will have fun and you will advance the science as well.
Yeah, that's exactly. Yeah. But the good people helps you maintain the morale when things are difficult and challenging, because, I mean, who in science can't recognize that? It's got its challenges.
Oh, yeah. Oh, yeah.
So, at least if you can be working with good people, those challenges can kind of be spread out a little bit.
Yeah, you can deal with them a bit better then. You have the support system then. Yeah, that makes sense. And speaking of the challenges, a little bit around the challenges front, I hope your research experience has been wonderful so far and will continue to be wonderful in the future as well. However, if you have 3 wishes to improve your research experience, I know probably you have like 50 zillion wishes, especially with the toys, but you have 3 wishes. What would you ask for? And I'm not promising anything here, okay?
No. I'll hold you to all of these, of course. So as somebody who's been a PhD researcher and a student at the CNBP, I've been really lucky. I probably harp on about this too much. The support and the encouragement. My supervisors are just they're truly brilliant scientists. They're kind people. They are generous with their networks and their opportunity. But in the CNBP, you've not only got your immediate supervisors and lab group, there's also this extensive network of all the different nodes and all the different groups within the nodes, and our leadership, the administrative team, everybody who's involved at every sort of governmental level within the centre. It's like having this huge network of supervisors and mentors that you can tap into with all really unique, weird, wonderful experiences and perspectives. And so it's just, there's always somebody to kind of help you nut out a problem, whether it's scientific or career or whatever. And then of course comes off the back of that access, like I said, all the cool toys, or the expertise to help you with the cool toys. So as far as I think all my research goals go, I've been really blessed and really lucky to be situated with more toys than you can poke a stick at, and just the people, really, which is the expertise, the people. You can have all the toys, but if you don't have those people who are willing to help you and teach you and spend time explaining why your experiment didn't work, etc., then it's all for naught. But I think again, going back to this, I've had episodes of depression my entire life. I can remember now, looking back, having it when I was even quite young in primary school, and just varying levels and degrees and things like that. I'm fortunate though. I mean, I'm healthy and I'm doing really well, and I'm for the most part can manage it, and I don't really have any major episodes at the moment to speak of. But I think one thing I'd like to sort of see, and it is slowly happening, I just think I'd like to see it happening a little quicker, is this normalization of going to mental health experts and talking to mental health experts as a PhD student or just even as an academic. Normalizing that what we do is inherently difficult, it is stressful, it comes with that, and that's just the science. But the whole broader structure and systemic problems that are starting to get discussed can cause a lot of stress and mental anguish. And then when you multiply that by what's going on in just your personal life, I think normalizing going to a therapist, even if you don't have an underlying mental health issue, going and talking to somebody about the stresses in your life, and normalizing that, like a professional, like your supervisors can be great and supportive and talk to you about ways that you can make your work-life balance happen. But going and actually speaking to a healthcare professional who it's their job to help you self-reflect and understand why a particular thing is triggering you into stress or anxiety or depression. I mean, I think that's, if you've got a toothache, you go to the dentist. Mm-hmm. But when we have a brain ache or a heartache, we're not so good at going to the specialist and dealing with that issue. And I think, to me, I'd really like to see people normalizing just going to a mental health care professional just because it's been a big, long week and you want somebody to debrief over that big, long week with, and somebody who you don't have to worry about dumping on them. That's their job. You dump on them. They go and manage that on their own. Whereas, sometimes when it's your supervisor or somebody you work closely and intimately with, really doing that can be, well, maybe they don't have the coping skills. Maybe they're going through a lot as well. But whereas if we go and see a professional, that's their job. So we're not burdening anybody with anything. And I think I'd like to see that. I'd like to see, and that's one of the reasons why I talk openly about my mental health and around those sorts of things and the importance of support and working with good people, because they all help. It's all interconnected. It's a big system. Right. I also, now in Australia, it's the way we handle PhDs. We're called students, and throughout the course of my PhD, I have a bit of a problem with this. I don't have all the answers, of course, but I think in Germany you have more of a model where a PhD student is more of a staff member. They're employed in a different way. They're not called students. And I think also there'll be universities with subtle differences to all of this. But I think there's this, we sit in Australia in the current system and the way it's set up as a student. We sit in this sort of grey zone where, yes, we're a student, but we're also doing a job. Mm-hmm. We're generating data and research and producing papers and going to conferences and doing everything that the other already academics do, but we're called students. And yes, we're learning and we're trainees, but I think as somebody who's done a formal apprenticeship under the Australian method, I think academia has could learn a lot from the way the trades union and the government sort of came together to get rid of and resolve, not get rid of, but to kind of help understand some of the underlying issues that back in the 80s and before, Australia had a pretty bad reputation in the chefing world. You know, of apprentices being abused, neglected, underpaid, overworked, bullied, harassed, and they were finding it hard to fill roles, actually get enough people to take on apprenticeships. And there was a big movement to improve that quality of training and care given to apprentices. So essentially, your apprenticeship is to the government, and you're paid by your employer, but they get subsidies, and your education is subsidised, which is very similar to a PhD here. It's all subsidised. Well, if you have an Australian placement, it's quite heavily subsidised. But what they have in the trades to combat the harassment and the bullying that was happening was they implemented an external person who wasn't government, who wasn't from your employer, who'd actually come and check with you once a year. And they would ask you questions, and they would observe your workplace, and they would observe you in your workplace, and they could just show up. They typically would sort of tell you when they're coming, but if they thought or they'd had a complaint, they could just show up, and they'd be like, I'm here to do an observation and check on you. And if they got even a whiff that a company or a business or a chef was being abusive or you weren't getting paid, they could ask to see all your pay slips, all of these sorts of things, ask to see how many hours you're doing, look at the rosters, all of those sorts of things, and really check up, was your boss really treating you according to the standard and the principles that the indentureship, as it is called, laid out. And it sort of strikes me that's perhaps something that academia could benefit from, and the government, you know, in Australia, as an Australian citizen and resident, my place is heavily subsidised by the public purse, and I feel great responsibility to ensure then I do a good job, because it's, you know, it's public money. But also, I think maybe it's time that we had a checks and measures of somebody that comes in and makes sure that, you know, the quality of the training and also the quality of the environment that PhDs, like candidates and students are involved in is actually up to scratch, and it's healthy. And this isn't to get individuals who maybe aren't doing a good job into trouble, but just to kind of recognise that maybe that person needs more training on how to be a good mentor and a good manager, because maybe they didn't have that themselves, so they never learned. And I think maybe formalising some management and project management early on in our careers as academics could go a long way to really helping resolve some of the issues that we're hearing a lot of people talk about in the academic world, around, you know, people being overworked or underpaid, or, you know, whatever the issues are, and that's a systemic thing. That's something it's a global issue, I believe. But in Australia, I think we could put in some checks and measures that might help to capture those, that my colleagues, my fellow PhDs that don't have supervisors maybe that are as strong mentors and strong support, maybe help capture them before they fall through the cracks, and become another dropout statistic, and also help their supervisor to sort of reach their full potential in that role as well, you know. So yeah, I mean, I honestly don't think that most people, it's not a nefarious thing. It's not people sitting there going, I mean, there might be people out there. I think most of the time when people don't treat their staff or their students well, it's just because they don't necessarily know any better. They don't have those skills themselves. And I think we could do better in teaching and training and just encouraging that whole environmental shift and community shift. So, but yeah.
Okay, so those are the two so far. The talk more openly and have some sort of support system and normalize talking about mental health, and make sure that there is some equivalent of PhD union-ish, not really union, but more like making sure that everyone is happy, making sure that everyone is healthy physically and mentally as well, and making sure that this is regulated and controlled in a proper structured way, sort of. That's quite interesting.
It's about making the expectations really clear, to everybody involved. And that's what the apprenticeship, essentially the apprenticeship union and the government, they made it really clear what the expectation was. So there was none of this, but we didn't know, because it's like, well, if you don't do the right thing and we catch you, then you don't actually get another apprentice.
Okay, that's very strict. Yeah. That's when people take it seriously, I feel. That it's okay if you don't know the rules before going into the job, but once you are in that position, you should know the rules that you should abide by. And if you don't know the rules, then you have to pay the price. It's like a traffic ticket.
But also just from the kind of, okay, so you haven't developed that skill, or nobody maybe your supervisor wasn't particularly great at this sort of thing. So we've recognized that maybe you're lacking in this little area, this one area, but we expect you not to be lacking in that. But so here's how we think you should go about it. And so like I said, it's not about getting people in trouble unless they become severe repeat offenders. And then it's like, we've tried everything and that's it. I think it's maybe a little bit of racking on the knuckles to keep people in check with how they treat their staff, right down to their students. It can, I think it always needs to initially come from a place of what we want to do is make sure everybody has the tools. You need the tools. If you don't have the tools, then of course you can't do a good job. And those core skill tools of being a good manager, and a mentor, and what that means, how to change your, as a chef, I had to mentor and train lots of different apprentices, and the onus was on me to change my mentoring style for each of those. There were still core things that stuck with me, but I would, certain tasks I'd be like, well, they're not getting that. So maybe if I just change tack a little bit here, some apprentices I'd have to be a little firmer on, some I'd have to be a little more gentle with. And you adapt that way to suit their needs in order to get the best out of them. And that's something that for me as an apprentice chef, I certainly had good mentors in that. They would guide me through that process. When I was doing my apprenticeship, I was given a student, an apprentice who was a year younger than me, and I was Emmy, you're going to show them how to do these tasks. They've just started here. And I'd be like, okay. And if I wasn't doing a good job, my chef would pull me aside and go, next time you explain it to them, or this happens, try this and say it like this instead of the way. And, and it wasn't like I was getting in trouble. It was just okay, I see what you're getting at, but maybe if you just do it this way and show them again, and then, it's that sort of thing, being stepped through the mentoring process as I learnt it, so that I was able to develop those skills. I was, again, lucky to have that and see that. But you can only learn to be a good mentor and a good manager by having good mentors and managers.
Yeah.
So,
Absolutely. Do you have a third wish as well?
Pardon?
Do you have a third wish?
I feel really guilty asking for something else because I've been really lucky. I'm sort of everything. The things I'm really asking for are such big global things. I don't know, a writer monkey to write my thesis. I hate writing. I'd love somebody else to be able to write my thesis. I know they can't. But yeah.
Okay, that I completely relate with. Absolutely, the third wish that I would. There were so many times while writing my own thesis, I was talking to my friends and my colleagues, and we're like, okay, I'll make you really good food if you write this part of my thesis. But of course, it didn't happen because I'm the one who has to, the PhD researcher. You have to write your own thesis. Yeah. But yeah, I did give in to temptations every once in a while. But my support system was quite strong enough. It was like, we would love to have the food, but not in exchange for writing your thesis for you.
It is the price you pay for getting to play with fun toys. Is to write the thesis. So
that's how I see it as well. That I got to spend so much time in the lab. So this is the price I'm paying, writing, because I'm not a big fan of writing. Super. Yeah. So I hope that all three wishes, especially the first two, I think those are really, really important points that you raised, and we should definitely work towards it as a community, as a society, as a scientific community as well. And I would like to believe that at least the first, that speaking more openly about mental health and making sure that you're healthy mentally and physically. I hope we are working towards it. I think there is a lot of awareness that is happening slowly, but it would be great, as you mentioned, to have it happen as quickly as possible.
Yeah,
That's
and just
very important. Yeah.
it's always, I guess, for me that it's the growth. It's always just as long as the trajectory is moving in the right direction, and that requires having difficult conversations, and it requires, maybe putting a few noses out of joint every now and then, but and also, I get sometimes particularly around the mental health thing, I get some people kind of sending me messages, aren't you afraid that maybe a future employer will see this and they won't hire you? And I'll be like, well, then I've just been my own gatekeeper for somebody I don't want to work with.
Exactly. I said the exact same thing.
If they can't see beyond that, I don't want to work for them. They don't deserve me.
Yeah, absolutely, completely on the same page. Like, I do not want to work with someone who has an issue with myself, like who I am. Absolutely, I completely agree, and I really, really hope that we are working towards it and approaching it quickly, and that becomes reality soon. And speaking of future, what are you most looking forward to in the next 3 months?
That's a really challenging question for me at the moment. I'm writing a thesis, working part-time, and all in the middle of a global pandemic. Doesn't seem to be a lot of end in sight. No, I'm joking. Of course I'm joking. I'm actually, I've sort of alluded to this job at the NRL that I've just recently started. I'm actually really looking forward to doing that. I'm looking forward to getting my thesis done as well, but I'm really looking forward to this job. So just to kind of touch a little bit on this job, it's essentially taking rapid diagnostic kits that have been manufactured and testing them and validating them to make sure they work according to the Australian standards, and that they are sufficient diagnostic with sufficient specificity and sensitivity to pick up COVID in the population, but much more rapidly than our current testing. So not making any promises on this one, but basically what I'll be doing is we take patient samples and then we test them we test the kits against these patient samples, and we do hundreds and hundreds of these for each of the different types of tests. And then the scientist in charge will write a report based on our findings and the results to grade the different tests. And then the government will be able to use that, and the health department will be able to use that to decide which of these tests, if any, meet the Australian standards according to diagnostics, and then whether or not they want to implement them based on that. So it's a really important part of the process to help ensure that when you take a test, first and foremost, it's not going to return a false positive and give the patient undue worry, but also it's not going to return a false negative and put public health at risk. So we really put these through their paces, and we check them under lots of different conditions that would replicate the sort of the clinical situation where these would be being used when they get rolled out to market. And I'm really looking forward to that. I'm a bit of a weirdo. I like reading standards and regulations. I think there's something soothing about them. They are dry and boring, yes, but I kind of like it. And this is heavily regulated work. But I also, again, it's coming back to this whole principle of doing something that is going to have an impact and potential immediately help my community. If we can come up with ways to help people get back to jobs and school and sort of a kind of a post-COVID normal life they talk about, if I can do something to help, then it's worth the extra hours that I have to put in on weekends and things like that to make up time that I'm taking out of finishing up my PhD. And and it's, again, working with really cool people on a really cool project, and it's a little bit invigorating. So I'm looking forward to doing that work. I'm looking forward to having a little bit of a taster again about what it might be like to work in industry. It's a very similar sort of process to working in industry, opposed to pure academia. So I'm looking forward to sort of testing those waters as well, in case that's an option I want to go back to, go out and transition out of academia. Particularly with the climate, the job climate in Australia in academia, there's a lot of people I know are worried about job losses, and rightly so. But yeah, so I'm looking forward to that, and I'm looking forward to maybe having a holiday sometime in 6 months. But definitely, even if it's just taking some weeks off and having a little mini break, even if it's just at home with my dog and my husband.
That's nice. That's very nice. You can treat that as a reward after you write your thesis.
Yes.
Or part of the thesis. That's what I did. Okay, I'll finish my first version and then I'll go on a really nice holiday. And it did work, I must say. It did work. So maybe you can try that.
I like that. That's a great tip. I'll take that under advisement.
I'm really, really looking forward to what you mentioned with the COVID-19, the rapid diagnostics. I really hope you can dive deeper into that while you're curating the account, so that we get to know what exactly you're doing. And that sounds absolutely fantastic. And Emma, this has been lovely. But before we let you go, I have one more question for you, and that is about the challenges faced by the field of materials or nanoscience. So what do you think are the challenges faced by the field? Like, what are the scientists working towards solving?
Well, I mean, I think nanomaterials and nanotechnology as a whole is working to solve problems that are across everything, from quantum computing problems, data storage. There are biomedical implants, diagnostics, different tools for just studying different areas in biology, chemistry. It's really across so many different things. Antibacterial. I mean, I just know so many people working in nanoscience, and I don't think barely two of them work in exactly the same thing. It's such a broad and fascinating field of science. Right. But from maybe something more closer to my exact area, which is the fluorescent nanomaterials for biological applications. I think probably one of the biggest issues there is that this is compared to, say, fluorescent dyes and compared to fluorescent protein even, and other ways that we look to study biology, nanotechnology is really new. It's infantile compared to those sorts of sciences. And I think that nanomaterial scientists and nanotechnologists, we come out with such enthusiasm around our fields and our work because we're so passionate about it that sometimes we can maybe sound like we're going to solve all the issues in the next sort of 10 years. We kind of can sometimes make promises that it comes from a genuine place of like, yes, we can do this. We've got this. And that enthusiasm has allowed us to make massive leaps and bounds in nanotechnology, huge ones. But when I was talking with one of my supervisors, Lindsay Parker from Macquarie University, about this, and when we consider fluorescence materials used to study biology, there was a good 90 years, or if not longer, between the first fluorescent molecule that was used in sort of biology to things like the Alexa fluorophore dyes. There was a huge time between those developments and really where we are now with that technology, which is an amazing technology for studying and understanding biology and things that are going on in the biological environment. But we're maybe 20, 30 years into bio-nanotech or nanotechnology, really. I know people have been playing around with nanotech stuff for, a bit longer than that, but really where it sort of started kicking off, really getting interest is really, really new. And I think our biggest challenge is patience with ourselves to make sure we're trying to understand things, sort of walking before we run, kind of patience needed a little bit with making sure that we truly do understand them from the safety perspective to the way that it behaves. Things get weird at the nanoscale. What's happening at bulk and in the big world, it gets weird down at the nanoscale. So, really making sure that we're taking the time to explore and understand that is really important. But also, in our way we communicate our science to the general public. Of course, we want to get them enthusiastic, but also this combating this immediate gratification thing that goes on in the world, that things like movies and Hollywood have really perpetuated, that you can go to a crime scene and take a swab and within 20 minutes you've got the criminal all under wraps, or you can go in and your patient's sick and you diagnose them and it all happens like this. I think that's that patience. Things take time. Good things take time, and safe things take time, or they take a lot of money. We're getting things done quite quickly with COVID in as far as these vaccine developments are happening very quickly, but there's a lot of money being thrown at them. So, it's that whole triangle of you can have it fast and expensive, or you can have it slow and cheap, but we can't have all three together, sort of thing. So, yeah. So it's so I think that's it. I think it's just it's patience while maintaining that enthusiasm and that kind of resolve to solve big world issues. I think for me that's Yeah,
that makes sense, and I think that's a very nice note to also end this conversation. This has been lovely. What we need is patience, and money and everything needs to fit together. So be patient, people. Be patient. Nano is going to change the world, but one invention, one step at a time. So be patient.
Yeah.
Absolutely. Super. So, Emma, this has been really, really nice. I enjoyed our conversation a lot. I learned a lot. So thank you very much for that. And we are very, very excited to have you on Real Scientist Nano.
I'm really looking forward to it. And thank you again for the invite. It's been really nice talking with you.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.